problems. Half-life, doubling time, tripling time. These have applications all over science, okay? The most common stuff is half-life. Here's the formula. They write it out all these different ways. This is it. A is equal to A naught. Oh, it's C to the T over P. Okay. Let's talk about this formula. A is the final amount, or the amount at a certain time. Okay, the amount of time T. Now, a lot of people say A0. I had English professors in university, and instead of saying 0, when you have a leading 0, this is a total aside that you don't need to know, but you're going to hear me say it. In North America, they would say 0.5, right? In England, they would say 0.5. And it's the naught is NAUGHT. Okay? Means 0. Okay? Anyway, so I call this A naught. You can just say A0. Okay? But what it is it's your initial amount, the amount that you start with. Okay? All of this should be on your formula sheet, by the way. C is your base, okay? Because it's raised to an exponent. So it's this is an exponential function. Because C is your base, and it's raised to an exponent that is a variable. Now, it changes depending on the question. If I say half-life, C is 1/2. If I say doubling time, which they use in bacterial growth all the time, it would be 2. If I say tripling time, 3. If I say quadrupling time, 4, right? All right. T is time, like actual time, 5 minutes, 10 minutes, whatever. P, now this is, people screw these two up, mess these two up, sorry. T is the time it takes to run the experiment. P is the time it takes to double, or the half-life, or whatever. So if I say it has a half-life of 5 minutes, P is 5 minutes. Okay? And the one thing about T and P is they must be the same units. Because if they're not the same units, then your exponent is going to have units, and that doesn't really make anything. Make sense, sorry. They have to be able to cancel, so they need to be in the same units. All right, so let's just practice doing these types of questions. Patient feeling ill had a sample of bacteria taken from her throat. The sample contained 387 cells. 24 hours later, the sample was recounted and found to have contained 8,012. Find the doubling period of the bacteria to the nearest 10th of an hour. Okay. First thing you do is write down your formula. A equals to A naught C T over P. And then off to the side, this is how I do it. I write out all the letters. All right. A naught, the initial amount. How much did we start with? 387 cells. Everybody agree with that? Okay, 387. So A naught is 387. 24 hours later. What does that represent? Time. T, the time the experiment took. 24 hours. Was recounted and found to contain 8,012 cells. What is 8,012? What letter? A, it's the final amount after a certain amount of time. 8,012. Final sentence. Find the doubling period. What does that tell me? That is your base, C. Okay? So your base is 2 because of the doubling period. And then it's saying find the doubling period. So it's saying find how long it takes for the cells to double, which is our p-value. That's what we're trying to find. Plug it all into the formula and solve it. So there we go. Now, do not multiply 387 times 2. Why not? They don't have the same exponents. Okay? This 2 is tied up with all this stuff, so you cannot multiply these together. Please don't do that. That is a common mistake. What are you going to do with the 387? What's the only thing you can do? Divide it off. So if I divide by 387, I get 20.7 is equal to 2 to the power of 24 over p. Okay, so now I've got that. This is like every other exponential stuff we did yesterday. We have an unknown in the exponent. What is the only thing you know how to do that will knock down an exponent? Log it. So you have to log both sides. Does it matter what log you choose? But what log does it make sense to choose so that you can put it in your calculator? Two choices. Natural log or log base 10, right? LOG. I don't care which one you use. I'm assuming everybody wants to use LOG. So that's what we'll do. So I got log 20.7 is equal to log base 2 of 24 over p. Okay. What happens to 24 over p? You bring it down. All right. Now it's algebra. I need to get p by itself. I don't want it in the denominator, so how am I going to get rid of it or move it? Sorry? Yes, you're going to multiply it up to the other side, right? We need p times log 20.7 is equal to 24 log 2. Final step. What am I trying to solve for? P, so divide off the log 20.7. And if you punch that in your calculator, you should get about 5.5 hours, which is the time it takes for the bacteria to double. I would punch that in your calculator just to make sure that you're... I'm going to ask you to do that on the test, so you might as well just practice it right now. 11:20 do we end today? Yeah. 11:10? Really? All right, 11:10. Let's go then. Any questions about that? It's the same step every time. Write out your formula. Write out what you know. Plug it into the formula. Solve for your unknown, which is probably going to involve logging it. I'm going to do this one right below it. Half-life. In 1986, the nuclear accident at Chernobyl contaminated the atmosphere with quantities of radioactive iodine 131. Half-life of it is 8.1 days. Determine the number of days to the nearest day it took for the level of radiation to reduce to 2% of the original level. Has anybody actually gone on YouTube and looked at like when they send drones into Chernobyl City and stuff? It's really cool because it's just like abandoned. You should look at that. That will not be on the test. Anyway, if the half-life is this, how long did it? Okay. Write out all our variables. A naught, C, T, P. All right, the first sentence is just setting stuff up. Second sentence, half-life of radioactive iodine is 8.1 days. What number, what variable is that? P, right? It is the half-life. It's the time it takes. So 8.1 days. Determine the number of days to the nearest day. So what am I looking for? You're looking for T. Boom. It took for the level of radiation to reduce to 2% of the original. Okay, first of all, we're talking about half-life. So what letter is that? C. C is 1/2. Now, they don't tell us the initial and they don't tell us the final. All they say is the time it took to reach 2% of the original. So the original, we don't know. So it's still A naught, okay? A naught equals, I'm just going to write A naught. We don't know what it is, so we're just going to leave it as A naught. How much do we have at the end? 2% of the original. Original is A naught, right? 2% of, what does of mean in math? Times. How do you write 2% without the percent? Boom. So A is equal to 2% is 0.02. And it's 0.02 of the original. So of A naught. Okay. You don't actually need to know the initial or the final amount as long as you know the relationship between that. Plug all that into our formula. So here's our formula. Plug it in. So A is 0.02 A naught. A naught is A naught. C is 1/2. And it's T over 8.1. What happens to the A naughts? They cancel out. They go away. So now I'm left with T over 8.1. We have an unknown that's in the exponent. So what do you have to do to knock down the exponent? Log. Doesn't matter what log you use. I'm going to use natural log this time just because I like writing the ln. You can use log. And the T over 8.1 will fall down. What do I do to solve for T? Multiply the 8.1 up. And then yeah, divide off the natural log 1/2. And then if you plug all that into your calculator, you're going to get about 45.7 days. They wanted the nearest day, so it rounds to 46. Is that okay? I'm going to do one last one. and then we're done. It's on the next page. All right, use the formula. Okay, it's our formula. We don't have to rewrite that. C is equal to 1/2. Yes, we know we're talking about half-life. How much of the isotope must initially be present to decay to 60 grams in 14 years? We're talking about an isotope that has a half-life of 7 years. So fill in your number or your letters, please. Is that what people got for the letters? The variables, I should say. A is 60, because that's your final amount. A naught is what we want. C is 1/2, T is 14, P is 7. We good with that? All right. Punch it in, so you get 60 is equal to A naught 1/2 14 over 7. What's 14 divided by 7? 2. 1/2 squared is 1/4. How did I get rid of the 4? Multiply it up. 60 times 4 is 240. 240 grams was initially present. All right, we're done. Practice questions you should do are 8, 9, 11, 12, and 13. Yeah. Actually, I'll do 15 too, because it's the kind where it doesn't have the initial amount given to you. All right. That's it.